I will now begin the fourth lecture on food labeling and advertising regulations in South Korea. I am Dr. Danny Jun, the CEO of FSIRI, Food Science Information Research Institute. Our institute specializes in providing lectures, consulting, and OTT services related to food. In the third lecture, we learned about ingredient labeling. In this fourth lecture, let's take a closer look at the first half of nutrition facts labeling. In more detail, we will study mandatory labeling food and nutrients, Nutritional Aanalysis, Allowable Measurement Deviation, per unit for displaying nutritional content, and Calorie Calculation. This is about mandatory labeling food and nutrients. The enforcement rules of the Act on Labeling and Advertising of Foods establishes the obligation to declare nutritional information for certain food products and specifies the nutrients subject to labeling. Some food products subject to mandatory nutritional labeling are listed in this table, and the number of food products has been increasing every year. While not mandatory labeling food, businesses can voluntarily provide nutritional labeling. Furthermore, the same enforcement rules define the mandatory nutrients as 9 items: calories, sodium, carbohydrates, sugars, fats, trans fats, saturated fats, cholesterol, and protein. When a business operator voluntarily provides nutritional information for a food that is not subject to mandatory nutritional labeling, they must display the nutritional information in accordance with the standards for labeling of foods. Therefore, if you want to display sodium for a food like agar that is not subject to mandatory nutritional labeling, you must display the 9 mandatory nutrient, including sodium. For beverages subject to mandatory nutritional labeling, when emphasizing components such as vitamins that are not among the 9 mandatory nutritional components, but are present in the daily nutritional reference value, you must display the names, amounts, and percentages of both the 9 mandatory nutritional components and the emphasized nutritional components such as vitamins, in relation to the daily nutritional reference value. This table represents a portion of the daily nutritional reference values for nutrients. This is about nutritional analysis. In the case of braised eggs, typically, only the nutritional content of the eggs is considered for calculation. Since the soy sauce is an inedible liquid added to maintain product quality. Therefore, the nutritional content of the eggs, excluding the inedible part which is the soy sauce, should be calculated and indicated. According to the standards for labeling of foods, it is stated that if 2 or more products of different types are reported as a single product for commodity reporting, the total amount should be indicated. Therefore, even in the case of products like ramen, which include noodles and soup, and are sold as a minimum unit, if the product is consumed after dilution, the nutritional content of the product itself before cooking, excluding the diluting water, should be indicated. If the ramen includes a tea bag that is used to brew the soup and the tea bag is removed before consumption, then the nutritional content of the brewed soup as consumed should be analyzed and indicated on the nutritional label. First, determine the unit of measurement based on the packaging form of the product. Then, convert the nutritional content received per 100 grams into the determined unit of measurement to match the net contents. This is about allowable measurement deviation. Unlike industrial products, the nutritional content of food can vary due to factors such as season, soil, harvesting, and processing methods, and the content can change until the expiration date. Therefore, permissible tolerance ranges are established based on nutrients. For essential nutrients that are easily underconsumed, such as dietary fiber, vitamins, and minerals, a value over 80% of the declared amount is considered acceptable. For nutrients that need to be limited in consumption, such as calories, fats, cholesterol, and sodium, a value below 120% of the declared amount is considered appropriate. However, despite these regulations, if the ingredient specification in the standards and specifications for foodies stated as equal to or above the declared amount, the actual measurement must be equal to or greater than the declared amount. Likewise, if the ingredient specification is stated as equal to or below the declared amount, the actual measurement must be equal to or lower than the declared amount. This figure represents the process of determining the per unit for displaying nutritional content based on the packaging form of the product, or the presence of serving reference amount for food. Please refer to it, and I will explain through a case study in the following slide. The bread packaged in bundles of 6, each containing 60 grams bagels, qualifies as a unit product. The serving reference amount for the bread is 70 grams. This product doesn't have a unit content exceeding 100 grams or the serving reference amount, and its total content is more than 100 grams, but not more than 3 times the serving reference amount, 210 grams. Therefore, it can be labeled per total content or per 100 grams. When labeling per unit content, total content or per 100 grams should be indicated together. The unit content refers to the weight or volume that can be divided into units such as pieces, slices, packs, or bottles. When determining the per unit for displaying nutritional content, factors to consider include whether the serving size is easily understandable, whether comparing nutrient content between foods is convenient, or whether calculations are straightforward. Additionally, when labeling per serving reference amount, the nutritional content per total content or per 100 grams should be indicated together. This is about calorie calculation. When carbohydrate content is labeled separately for sugar alcohols and dietary fiber, the calorie content of carbohydrates is calculated by summing the calorie content of sugar alcohols and dietary fiber. For sugar alcohols, the calorie content is calculated using 2.4 kilocalories per gram of sugar alcohol. And for dietary fiber, the calorie content is calculated using 2 kilocalories per gram of dietary fiber. The calorie content per gram of tagatose is 1.5 kilocalories, allulose is 0 kilocalories, and other carbohydrates are 4 kilocalories. Resistant starch falls under the category of other carbohydrates. Therefore, it should be calculated by multiplying 4 kilocalories per gram to determine the calorie content. When calculating calories, the content of nutrients like protein and fat is determined using the labeled values rather than actual analysis results. Using the labeled content of nutrients, carbohydrate calories are calculated by multiplying by 4 kilocalories per gram, protein by 4 kilocalories per gram, and fat by 9 kilocalorie per gram. For alcohol and organic acids, alcohol is multiplied by 7 kilocalories per gram, and organic acids by 3 kilocalorie per gram. If indicated as less than XX gram, the actual values are used instead of the labeled content. If it is indicated as less than gram, the actual value is used as is. We will calculate the calories based on the nutrition table. In this table, dietary fiber and erythritol are listed separately within carbohydrates. Since the caloric content per gram differs for dietary fiber and erythritol compared to carbohydrates, we calculate the carbohydrate calories by subtracting the content of dietary fiber and erythritol from the total carbohydrates content, and then multiplying by the 4 kilocalories per gram of carbohydrate listed in the right-hand table. Next, we calculate the calories for dietary fiber and erythritol by multiplying their respective contents by 2 kilocalories and 0 kilocalories. We also calculate the calories from protein and fat. Finally, we add up the calculated calories for carbohydrates, dietary fiber, erythritol, protein, and fat to get the total calorie count. I will return to the fifth lecture. In the next lecture, we will learn about the last half of nutrition facts labeling. Thank you for listening. Please don't forget to subscribe and like.